I think we'll get started. So welcome everyone to our webinar. As an introduction, my name is Hind Ashraf Zaki and I work at the Qatar Research Development and Innovation Council. Today's webinar really a bit about QRDI, or the Qatar Research and Innovation Council. It is the research and innovation agency for Qatar, which aims to boost and fund research and innovation activities with the goal of realizing the vision set out in the 10-year strategy QRDI 2030. Today we bring you a webinar which is about innovation in football. And specifically we'll be covering two areas of innovation in football really. One is technology in football, which affects fans and players alike. And the second area is around stadium cooling technologies. And to do that, we bring you two fantastic speakers. The first speaker is Mr. Sebastian Rung, who is head of football technology at FIFA. The football technology team at FIFA are really working on solving problems in football by testing and implementing new technologies to enhance the football experience of players and fans on and off the pitch. I'm very much looking forward to the presentation from Mr. Sebastian today. Our second fantastic speaker is Dr. Saoud Abdelghani. Dr. Saoud is Professor of Mechanical and Industrial Engineering at Qatar University. He did his PhD in Mechanical Engineering at Nottingham University, and currently his fields of research include thermofluids, computational fluid dynamics, energy in buildings, amongst other areas. Dr. Abdelghani will be taking us through some of his QRF-funded research, which led to the designing and testing of cooling technologies in some of the stadiums that are hosting the FIFA World Cup in a few weeks. So before I hand you over to Mr. Sebastian for his presentation, I'd just like to say that how we're going to structure this session is we'll have two sections of the session. The first will be the presentation from Mr. Sebastian, and then we'll follow that with Q&A. So we invite all our attendees to send in Q&A through the chat at the bottom of the screen that you'll have. Please send in through your questions and we will address those at the end of the Mr. Sebastian presentation. The same for Dr. Saoud. If you have any questions, please send those through the chat and we'll address them all at the end of the session. And we hope to conclude in about 1 hour, 15 minutes. So with further ado, I will now hand over to Mr. Sebastian.
Thank you very much. It's an honor to be here. I'll just quickly share my screen. I hope this is coming up. Once again, thank you for being here. Thank you for having me. I work at FIFA in what we call the Football Technology and Innovation Department. And our mission is to harness technology to improve the game. When we say to improve the game, we are specifically looking at the action on the game, on the field of play. We're looking at players, we're looking at referees, a lot of officiating technology is what we call it, but we're looking at performance data as well. We're looking at the coaches, the analysts, and ultimately at what the fans at home, but also at the stadium get to see. And of course, innovation has been playing a big role in all of this. But at the same time, we have to ask ourselves, and that's where I would like to start, is why do we innovate in football? After all, it is the biggest game in the world. You could argue, why change anything? There's this famous statement, never change a winning team. But of course, no one is perfect. And we also have to consider what is happening around us, and we also have to accept that mistakes are being made. And I started in FIFA approximately 10 years ago, just a little bit more than 10 years ago. And this was a really interesting time because two things happened just before I started. And those were moments in the game that could be considered scandals. And one of them was this famous moment, and some of you might remember that. Frank Lampard scored or scored not a goal during the 2010 FIFA World Cup in South Africa against Germany. And the assistant referee and the referee were not able to see what happened. They did not see that the ball clearly crossed the line. And you can see from the face of Frank Lampard that he was not happy about it. And considering everything that is happening in football, how much money is circulating in football, and how important these games are, this was, of course, something very difficult to accept. Even though, me being German, I would argue ball wasn't in, but I think that's a very hard argument to make. But there were a couple of funny images online after that moment, and ultimately it just showed that it was so clear and it was so shocking that people could not see it, that something had to be done. Another moment just before that tournament was a famous handball by Thierry Henry in a qualification match against Ireland. And he clearly handled the ball before he scored the decisive goal. And if he wouldn't have scored that goal, France would not have gone to the World Cup. And as you can see on the picture on the right, this had a huge impact. All of the media, especially the UK media, was shocked. That was the headline the next day, the next weeks, and everyone talked about that moment and that it's simply not fair. So we had to look into that. And when we saw what happened back then, we started looking into technology as a tool for referees for the first time. But of course, there's so much technology available and so many innovations are being presented to ourselves on a daily basis. So we had to ask ourselves where to start. And when we think about innovation or the next big technology in football or any other industry, we make use of the design thinking framework. And I'm not going to explain that in detail now. I just want to explain to you how we organize ourselves within the football technology and innovation department and what kind of cycle we go through. This is certainly not something that we came up with or have invented. I'm sure many of you have seen it before. We just use it to structure our innovation cycle. And FIFA works in 4-year cycles, as you can imagine, from World Cup to World Cup. And in between these World Cups, we are working on the next World Cup. And we have to decide how we want to impact the game with technology or innovation. If you just look at the outer circle, you will see that there's one area that is understand, there's a second area that is explore, and a third area that is called materialize. For us, the first part, understanding, is extremely important. And we're not trying to solve problems that simply do not exist. We try to speak to players, try to speak to coaches, fans, the media, to better understand what is really impacting them when they watch football or attend a FIFA competition. And especially the feedback from the players, the coaches, the referees had a huge impact over the years. Because people can argue whether VAR is the right technology for football and if it's taking away emotions. But if you speak to most of the players and especially the referees, they don't want to live without these technologies anymore. So that's the first step. We have to understand what is the problem we're trying to solve. In the exploration phase, we're looking at the industry to begin with. We have to understand what is already available, but we also want to assess the quality of these technologies. So we are working with a lot of universities, research institutes, to better understand how good are those technologies. We're sometimes looking at different sports. In the case of goal line technology, for example, back in the time, we knew that tennis was using a similar technology for a long time, but could have been applied in the same way. Ultimately, it's a different sport. But it was certainly an interesting journey we went on to find out what the real differences when it comes to technology are between these sports. And then when we feel confident, when we have done our research, we feel like this technology can really add a benefit, we enter the final stage. And this is really the stage we are in right now. It is implementing these technologies. And we are just a couple of weeks before the World Cup. And this is exactly what we are doing right now. Myself, I'm flying to Qatar on Sunday. And hopefully all of the innovations and technologies that we are bringing are working. And then after the tournament, we enter a new cycle, and we once again will try to understand what is expected of us. I already alluded to a number of technologies that we have seen that we worked on. It's certainly not a complete picture of all of the projects that we are working on for the moment, but since we are close to the World Cup and one technology will be new, I would like to focus a little bit on these officiating technologies. Our journey so far, as you might have seen, has been from goal line technology back in Brazil, 2014, for the first time, over to Russia, where we saw the introduction of video assistant refereeing technology, to 2022, Qatar World Cup. And for the first time, we will see the introduction of something that we call semi-automated offside technology. But why and how did we get there? Why didn't we start with offside? Why didn't we start with video assistant referee? Ultimately, we had to understand what is already available. We're not living in a bubble, even though sometimes it might look like it. We have to understand what the world around us is doing. And one way of looking at it is to look at the development of data collection. Because if I overlay the statistic that is widely available in the market about the volume of data that is being created in our world, it's a statistic from the International Data Corporation. And this is including everything. This is certainly not specific to football, but it gives you a feeling for how the world of data has been developing over the last 10 to 12 years. The scale we're looking at is something called zettabyte, and I have to admit, I had to look it up. Apparently it's 1 billion terabyte, maybe a unit that you can relate to more than a zettabyte. And I'm quite sure that most of the data is quite useless and not all of that is relevant, but it gives us an indication to where the world is going with all of this. We see it in a lot of industries. Data-driven decisions are getting important, and algorithms and machine learning, artificial intelligence are playing a big part in all of this. For goal line technology, the key part was computer vision. We had video, we had to analyze the video because we needed certain logic, and then we had to make a decision. For video assistant refereeing, it was basically assessment of video material. But now, looking at semi-automated offside, we are entering the world of data-driven decisions. And I would like to explain that for a moment, because data-driven decision sounds already quite fancy, but it's quite important because the way decisions have been taken in football until recently were based on a single person or multiple people on the field of play, or in some cases with the help of video. But if we look at the example of the semi-automated offside technology that we will witness for the first time during the World Cup in Qatar, we're seeing that different technologies that have been available for quite some time are being combined. The picture on the left side is standing for optical tracking system. The optical tracking system in the past was a system that had multiple cameras, or sometimes only 2 or 3 cameras installed in a football stadium. And it was capable of giving you the position of every single player. But ultimately, it was only one coordinate, only one data point that you received by every single player. That, looking at the laws of the games and the offside rule, is not really good enough to make an offside assessment. So what we're looking at now, and what has been developing over the last couple of years, is that instead of one data point, we are seeing up to 29 data points. So we're not just knowing where that player is during the game. We also know where he's looking at, where his arm is moving, where his feet are, which direction he's running, and when he's kicking the ball. All of that can be assessed from optical tracking, video, camera, with the help of computer vision and artificial intelligence. But since there's a limit to how many images you're getting from a camera that is used for those technologies, we introduce a second technology, and that's the connected ball. You see on the right side, this is the official match ball for the World Cup. All of the match balls that will be played during the tournament will have a IMU, inertial measurement unit, a chip inside the ball that can give us a lot of different data points. But the one that we're mostly interested in for this use case is the acceleration of the ball. And by using that, we know exactly when the ball is kicked. And of course, you could argue the kick has to be differentiated from a bounce or when the ball hits the goalpost. But that's exactly where all of these other fantastic technologies are coming in. We apply a number of layers of artificial intelligence and computer vision again, and we can identify and filter the kicks that we're looking for. So if we now take that technology, knowing when exactly that ball is kicked, and the optical tracking technology, knowing where all of the players are on the field of play at a certain point of time, we have all of the ingredients that we need to solve the problem of offside and moving away from a purely visual assessment, looking at two players, hopefully having the right camera angle, to a data-driven decision. What I want to show you now is a bit of a sneak peek, a look behind the curtains. It's quite a busy image, and I'll show you a video in a moment where these images start moving. But I want to explain to you what you're looking at. This is the monitor the replay operator is looking at. So when you think about VARs, they have a whole team that is supporting them in the room to make decisions. One of the most important people is the so-called replay operator. That is the person giving the VAR the images that he wants to look at. Most of the time, a VAR is not operating the system himself or herself. That is done by that dedicated person. And that dedicated person is looking at a screen like this one. And you see a lot of different camera angles that can be looked at. And the big one on the right is the one that the VAR is looking at. You see there's an offside incident happening in that moment. You already see some lines. You see the ball is being kicked. And you also see that the players, the images are already being overlaid with what we call skeletal tracking data. So you see these little blue and red lines that indicate that limbs and arms have been identified. On the bottom, you see a timeline that is moving while the game is going on. And the system itself, with all of the technology that we just talked about and the connected ball, there will be events identified fully automatically. So when a player is in an offside position and the ball is kicked, there will be a flag. You see a good example on the bottom, there's an orange flag. That orange flag means there's a close offside decision. So until now, the VAR did not have to do anything. It was completely the system making the assessment based on the data that it has received. If we now play the video, you will get a feeling for how fast this is happening. You will see these images moving. You will see the player running. You will see the player passing the ball, crossing the ball, and then you will see these lines appearing. And this is the time it takes for the system to make the assessment. Let me just play that for a second. That was it. And I will play it again because it might have been a bit difficult to identify. But basically what happened is you saw the player running down here, passing the ball, and all of the things that we discussed just happened within a split second. So if I go back to that moment, you see how the system is doing the work. Oh, I was a bit too ambitious. I'll play it one more time. And you see when the flag appears, orange flag, and we have lines. So this is how offside decisions will be taken during the World Cup. It might take a bit longer because we want to be absolutely sure that that decision is the correct one. And that is the main reason, or really it is the reason why it's not called automated offside calling technology. It's called semi-automated offside technology, because we want the human, the VAR, to look at these decisions just to be on the safe side, that we're not making a decision based on data that could be wrong for whatever reason. In the end of the day, it's technology. Sometimes technology fails, and we just want to have that layer of safety with VAR looking at that data. There's more use cases for the technology, especially when we look at the ball that I mentioned before. I mentioned there's endless possibilities of making use of the data. For example, in the area of performance analysis, the speed of the game, the number of touches, the speed of the ball, the spin of the ball, all of that can be taken from the ball. And over the next couple of years, we will certainly see more of that coming alive. What we already see here is that this data can also be used to identify slight touches. We had a moment here during one of our tournaments where the VARs and the referees were not sure whether the attacker touched the ball only with the head, or if he touched the ball with the head and then with the hand. And from the video image, it is really difficult to see. But if we use the ball data, and you see it on the bottom left, you will see that it gives you a peak. And the peak in this graph means there has been a change of acceleration, and that means someone touched the ball. So I'll play this video for you, and you will see it's going back and forth a little bit because they're looking for the right moment. But ultimately, you will see that there's a first touch now on the head, and then there's a potential second touch on the hand. And I'll stop the video in the relevant moment here. You see two peaks. This is the first one where the head is touching the ball, or the ball is touching the head. And then there's a second peak where the hand is touching the ball. So that technology is not just allowing us to make better decisions in the area of offside, it's also helping us to identify whether a ball was touched or not. And in this case, the goal had to be disallowed because the ball was touched with the hand before it entered the goal. This is what you can expect for this World Cup, the World Cup kicking off in a couple of weeks. But of course, there's more to come. And if I go back to the graph about the data that I have shown you before and show you the data that is forecasted until 25, 26, you see there is no stopping. And again, this data might not be relevant for what we are doing in football, but a small part of that will most likely help us to develop the next technology or the next innovation in football that hopefully will make a big difference. Where I see potential is exactly the area that we just talked about. We talked about different tracking technologies. We talked about the future that we see right now with skeletal tracking data, and we talked about the center of mass that has been the state-of-the-art technology over many, many years. But in a few years, and we see the beginnings already, we will be able to not just identify 29 joints within your body or the body of the players. We will be able to identify a mesh. Basically, we know where the body begins and what shape each body has. We call that volumetric tracking. And it is certainly possible today with a lot of cameras and a lot of computing power in most of the cases. And in many cases, it's not available live, but the technology will develop and this will be available. And then, of course, it will not just enable us to make better decisions in the area of officiating, it will also potentially enable us to really dive into the game as a fan. Because the moment we have the data, we can dive into the 3D environment. The 3D environment will not look like a 3D environment anymore, because it will look like the game. And at some point, we might be able to just continue the game as a game like the FIFA 23 EA Sports game and continue the game in the way we would like to continue. So if our team is losing, we might take over control and play it ourselves. This is where this is going. I was told to keep it short. I hope I did. And I will open up for questions. Thank you very much.
Thank you very much, Mr. Sebastian. I think that was an incredibly fascinating presentation. So thank you again for that. We do have a few questions from the audience, so I'll go through those, and if you can answer to the best of your abilities, that would be great. One question is around, how do you protect your technology as FIFA? I mean, do you patent this R&D that you're doing? What are the efforts you make to do that?
Yeah, that's a really good question. And in the past, it has not been relevant. What we were looking for is to find the technology that can be made available to the entire football world. When we looked at goal line technology, it was never FIFA's intention to make money off that technology. We were more in a position to guide the market and the industry and to tell them what kind of technology we are looking for. And we were fully aware that, of course, these companies will then go to Premier League, Bundesliga, or any of the other competition organizers and will commercialize that product. But in the end, as FIFA, as the governing body, we have an interest in developing the game. And it's never just for us that we develop a technology or innovation. We want to see this spread around the world. In the area of data, it's a bit more complicated because we're also looking at data protection laws, and we have to make sure that we are not giving something away that could breach any of these laws. But that might be a different webinar at some point.
Yeah, I'm sure. Okay, great answer. And I'll allow a few more questions if people want to send in their questions, but we're receiving quite a few already. I think there's a question here that's around for anyone with a unique or innovative technology or solution that would help enhance the performance of referees. So, if there's a company or a person out there that has a potential solution, what's your advice on how they can bring that solution to life through football? What would you advise for them to do?
Yeah, and that's, of course, very relevant because we are being faced with that question almost on a daily basis. And I have to be careful to say, not to say, just contact me, because that might not lead to the most efficient solution. What we have seen whenever a company came to us, the most efficient way of selling a technology is to show us that it's already used and that someone in the football world, whether it's a player, a coach, an analyst, a referee, believes in that technology, that they see a benefit. Because it's not our job to go to the refereeing world and sell them the latest technology. We have to identify the problem first. And that's exactly what I mentioned earlier today, that we have to identify a problem that we want to solve. And if you can explain to us what kind of problem you're solving with that technology, we are more than happy to listen.
Okay, very good advice. Another question: would offside be finally fully automated anytime soon? And will that potentially mean no linesmen in future? And again, difficult question, but I think that's why.
Difficult question indeed, but an obvious one. I talked about why we call it semi-automated offside. It's just a matter of time before we call it automated offside. At the same time, we don't know yet whether that means that there's not going to be any assistant referees anymore. For the moment, we want to support the referees as best as possible with the technology, but we also have to admit that these guys are doing more than just offside. It's a team of referees that is looking at the game from different angles. They communicate with the players on the pitch. So I believe we are still far away from taking them off the pitch, but I think we are getting closer to something that we can call automated offside.
Okay, great. Another good question, and maybe you can this question, I'll read it slowly. Hello, Sebastian. As we know, football and especially FIFA World Cup is quite a historic tournament with numbers and figures to refer to. How would the new technology be fair to national teams who the human referee decisions weren't in their favor, like England versus Germany 2010 or the famous Hand of God of Argentina? Thanks. So I guess where human decisions are not fair, how does this new technology make it fairer?
Yeah, and that's exactly where we started. And ultimately, we had to look at how can we help? How many decisions can we help with? And this is certainly a discussion that we had when we started talking about the introduction of video assistant referee, because you could also argue to look at every single decision. You could argue whether you should look at the corner kick or every yellow card. But ultimately, it's a compromise between finding the most relevant decisions and not changing the game too much. And the Hand of God is, of course, a fantastic example. This one certainly, with the technology in place, would have been identified and most likely changed. But at the same time, we have to admit that not every single decision can be replaced by a machine or a computer at this stage.
Okay, very good. Another question. Obviously, the World Cup, testing new technologies and innovations in a World Cup is quite high stakes. So do you try and test the technology in other games ahead of a World Cup game, given the high stakes? Or do you, how do you test the technology before you really test it at a World Cup, per se?
Yeah, very good. And don't get me wrong, we're not testing at the World Cup. We are implementing at the World Cup. So we have passed the exploration phase and we believe in this technology. We've been testing the technology over the last 3 years, I would argue. We went to a lot of youth tournaments, Club World Cups. We went to Qatar a number of times to run the technology in the background. And we're also working with a lot of confederations and leagues around the world that help us, because FIFA doesn't have access to a league that is playing on a weekly basis. So with the help of Bundesliga, Premier League, but also UEFA, we found testing opportunities where we could test these different technologies in live and offline environment. And just a couple of weeks ago, we also went to Germany once again to test edge cases. We looked at what kind of crazy offside situations can occur when someone's laying on the ground or someone is outside of the field of play. How would that affect the system? So we've done a lot of testing to make sure it's working.
Okay, great. I think another question here, the game is played by humans with all human aspects. Now these human behaviors are assessed by technology in a way humans are not able to. How does this impact the game itself?
Yeah, it becomes philosophical. We see that development not just on the officiating side, we also see that development on the performance analysis side. And that's very interesting development, because coaches and teams are now also in a position to give feedback like they were never able before. They count every single step, every single touch. They have access to heart rate monitors. For the moment, it's a lot of data collection, but ultimately there will be software, there will be algorithms that can give you recommendations. Whether they should be used or not, it's ultimately to the coaches, to the people with success in the game. and make that assessment. But it's certainly available, and I believe it will change the game. Yes.
Okay. Will you be using drones in matches? Another good question. Is this part of your technology?
There will be drones for broadcasting purposes, yes. But that has nothing to do with any of the technologies that we just talked about, not for officiating, not for tracking. It's purely the video production. The other area where we see the usage of drone is on training sites. So many teams that are coming to Qatar have requested to bring drones to have that bird's eye view and to analyze their training sessions better.
Okay. Okay. Very good. Another question is around, obviously, you know, you're doing all of this to improve the experience for referees, for players, and for fans. So what's the process you follow to get the feedback and use cases of what's needed? You know, obviously you talked about starting with goal line technology, video assisted refereeing, and semi-automated offside, but how are you actually getting, you know, these use cases and defining what are the most important things to then work and do the R&D on them?
Yeah, it goes back to asking the players. When we talk about players, it's mainly through FIFPro, the player union. They, of course, have also an interest that we develop technology and innovation that is helping the players. And they give us access to a number of players whenever is needed to have interviews, to get feedback on certain technologies. We are also working with our partners. Adidas, for example, is key for the development of the ball, not just because they develop the ball itself and have to put the technology inside the ball, but as a big sponsor, they also have access to a lot of teams and players. So that's also very useful when we develop these technologies to get first-hand feedback from the players. Referees is a bit easier because we have a professional refereeing department within FIFA. We have personalities like Pierluigi Collina, who is extremely important to us when it comes to technology because he is certainly a believer, and they can also give us access to those professional athletes.
Okay. Okay, and I think we have time for one more question, which is a good question from an anonymous attendee, actually. Obviously, Sebastian, you talked about needing to, you know, you have a mix, it's not fully automated, so there's a mix of human interaction with the technology, and obviously that involves a requirement of training. So an attendee here has talked about potential issues in the past where referees may or may not understand the technology or know how to adopt it. So how can we be sure that the humans and referees will adopt the new technologies in the World Cup and future competitions fully? You know, how do you help make sure that that interaction between human and technology works well in future?
Yeah, and that has been a big discussion, especially after the introduction of VAR. In the beginning, when it didn't work well, people were quick to blame the technology, but then we also see a development that most fans also realized, okay, it's actually not the technology, it's the people operating the system. And the only solution here is training and guidance. We see huge progress when it comes to training. VARs are being trained, younger referees are coming up. They're used to the idea of using technology as a support tool, and they're really quick to adapt the technology. And the other thing that we have to achieve is that we have a consistent approach across the leagues, because today we even see that some referees might intervene and others might not in a different game. And of course, that's not the idea of the whole project. Ideally, we have to achieve some consistency, and also that is only achievable through training. Yeah.
Okay, fantastic. Lots of great questions. I'm afraid we do have to move on to the next part of the session. And if we have time at the end, we will, we'll invite you to come and answer any other questions that are remaining. So I will end this portion of the session now and invite Dr. Saoud to come forward. And Sebastian, if you could stay on the webinar as well. So if we have time at the end, then we can cover any further questions.
Will do.
Okay. Okay, awesome. Thank you, Dr. Sarood. I'll hand it over to yourself.
Assalamu alaikum, everyone.
Alaikum salam.
Right. So today we'll talk about. Can you see the screen?
Yep, can see the screen. It's not full. Yeah, now full screen. Thank you.
So I mean, one of the challenges at the time of the bid was about the weather, and on the FIFA, the players are at the center and the focus point of safety. At the end of the day, you want the game to start in a safe environment, thermal environment, and end in a safe environment as well, without any thermal injury that would be caused to the players, for the safety of the players and the continuity of the game as well. So heat in our region is maintenance of normal temperature in a hot environment depends on the ability of the body itself to dissipate heat. So players, when they run from one end to another end in about 15-20 seconds, these they exert a lot of physical work, and that physical work requires generating spikes of heat within the body, and that heat is not only calculated for the movement. We always burn more than what we need. So the amount of heat that is left in the body needs to be dissipated through sweat. So for the players, the ability for that sweat to turn from a liquid form, which is a latent heat, into a vapor form. This is how they cool the body. When the heat is stored, because, for example, the weather is too muggy, or the amount of moisture content in the area is very high, then this evaporization technique will be less, and that will put the player at a risk of a thermal injury. So the heat itself is stored in the core of the body. You have extra stress on the heart and the lungs, and the increased heart rate as well. And this will give me a high level of of stress on the body. So and then the player can start losing focus, and at the end the player could be put off by the body itself to protect the person. So a lot of thermal indices were used to measure that amount of how safe is the environment. There is something called discomfort index. There's something called cool power index, humidex, WBGT, which is wet bulb globe temperature, UTCI, and SET. And for example, FIFA is adopting, the medical FIFA team is adopting the WBGT for the players. So, and the WBGT, you can see it on the left hand side here. The WBGT itself is a function of the wet bulb temperature, is about 0.7 of that. That index is heat, is wet bulb. So why it is important to measure WBGT? It's a combination of humidity. Wet bulb is good indicator of external heat stress. There is a flag system by we adopted for workers and for the FIFA as well. I mean, not only FIFA using that, but the IAF is using that. WHO is using that as a measure of thermal stress. And in the FIFA medical book, this is the WBGT. In the FIFA medical book, they 90 minutes before the game, and then they walk the field of play and measure WBGT, and about 60 minutes before the game, they measure WBGT as well. And then at the end, they give a decision of it's a safe game, they can play normally, or the players should have a break in order to take water break, or it is not safe altogether to play. And this is the flag system that we use. So we always aim at a normal activities, which is less than the 18 degrees C. So if you have a stress, thermal stress, you have weakness, confusion, slurred speech, and loss of balance, and things like this. And these are what we advise even our workers whenever we have a thermal injury, then these are the steps to do. So with all this into mind, we went into a bidding stage, and then at the bidding stage, we knew that it will be like a concern that FIFA will say. So what is new? This is what we wanted to do at the bidding stage. It's a challenge. We need to turn that challenge into opportunity. We needed to show people how we are different, and our motto was expect amazing, and that's what is new. Why we are different? Because we wanted to offer the tournament, the stadiums in a close proximity. All these stadiums with a minimum travel time of fans and players, and there we put that it is thermally served tournament for open roof stadiums, completely open roof, and it's a legacy that will contribute to the global knowledge. And this is the moment that we had a confirmation that Qatar is not a bidding country anymore. It's a hosting country rather than a bidding country. This is Her Highness Sheikh Hamoza and His Highness the Amir, the father, and this is where we started to deliver because we won the right for organizing the game. So then it is not a leather bag full of air, as Sebastian showed us. Is a bag now even full of a load cell and accelerometers to measure acceleration in all the sides. So we have to, from architecture point of view, you have to make sure that the your portfolio of the program is offering and reflecting a religion, culture, heritage, and at the same time is functioning with all the FIFA required rules for functioning stadiums. Stadiums never change since the Romans. It's an open space, as you can see, where players, compete against themselves or against animals at the time as well. And you have stands where people and the fans watch their favorite game. And this is the field of play in the middle, although it's sand is still the same. You have the stands all around. You have vomitories. You have the players' tunnels. You have the VIP area and things like this. So did not change for long. And we didn't want to design stadiums. This is the Maracana in Brazil. You can see it's a very nice stadium which was used in the tournament. And then after the games, it went into a white elephant because of lack of functionality, and the sustainability case was not there for the stadiums to go on. So we wanted to avoid that in all the designs. So we don't want white elephants, and we have to think the tournament, and we think the legacy as well at the same time. So what is the business case for a legacy that will maintain the building functional all year round? So when players play, they are under the solar radiation. They have a lot of activity. The metabolic rate will be high. Heat will be emitted from the surfaces, and with evaporative cooling, which is the sweating mechanism, then the players will cool themselves. And all this under a normal atmospheric pressure and air temperature, relative humidity. So the principles are we have to provide shades to avoid sun exposure. We have to make sure that we have a prominent cover for the fans, and providing cool air to the pitch area. And on the match event is considered for us completely under open sky. So we have two stadiums that we have roofs, but the cooling package does not necessitate closing the roofs. I mean, the game is under an open roof. And this is how we approach the cooling itself. So on the fans, we are providing cooling through nozzles, small diffusers under each seat. For the players, we are providing like a cannon type of air that will pull that air from its place and put it to the players. And all this in a small micro bubble. And in exactly what you can see here, this figure, you can see that we have like a blue area, not more than 2 meters above the spectators and where people are in the field of play, is only a micro bubble that we're generating, and we're keeping as cold bubble all the time alive. And just above that, there is a mixing area, and then is the hot climate outside. And these are the stadium that we've done, and I hope that I think some of you as well is visited these stadiums. So that's Al Khor, and the architecture look of Al Khor is the inviting Bedouin tent, and it's a value, cultural value, and at the same time with a big fireplace at the main entrance for VIP and the opposite end as well. And it is its height is very imposing structure. This will be in the opening. This is Ahmed bin Ali Al Rayyan with the Mashrabiya facade. This is the Thumama, which is reflecting the tradition of the as a hat for Arab men. This is the Al Janoub Stadium, which is inverted both, and this is our education city, and it is like a jewel of knowledge within the educational city, and that's Khalifa Stadium and Lusail Stadium, Ras Al Abu Stadium as well, although it is not air conditioned, but we designed that to induce the air through the containers and make a draft between the north and between the south in its vicinity as well, to make sure that yes, it's designed for a winter game, but we induce air all the time for ventilation. So a lot of people are asking us why, if the tournament is shifted to winter, so why cooling the stadium? So if you are sitting with the metabolic rate is about 1.0. If you are moving in a light activity is 1.6, and one metabolic rate is about 58.2 watt per meter square. An average person will have a skin area of 1.8 meters square. So we are typically generating about how many laptops? I mean, we're generating about 125 watt per meter watt in just sitting position. And if you see that a 50 watt of heat will be the heat coming from the processor of a laptop, so we are putting about 2 to 3 amount of heat coming of the laptops while we're just sitting watching the game. So if you imagine that Lusail is about 80,000 spectators, and each one of these spectators is emitting about 2 laptops of heat into the space. So I have 160,000 laptop in a small proximity sitting for about 4 to 5 hours into a space. So I need to offset that amount of heat even in winter time. And for our legacy cases, we consider that these stadiums would be hospitals, university campuses, school, community halls, local markets, and we can use it for social events and hotel. And already, for example, Khalifa Stadium won the right to host at the time 2019's World Athletic Championships. And you can see here that people enjoyed that World Athletic Championships, which were played in Doha, and it is on record the most World Championship with athletics. The athletes themselves broke their personal best, and the world records as well was the top till now. It was the top tournament where we have the highest events of breaking the world records and personal best for players. And I was there asking players, why you are now breaking your personal best, and the simple answer is that we are competing outdoors in the open as if we're competing indoors, and they are not afraid of the thermal injury. So what were the design tools we used? We use computational fluid dynamics. We use wind tunnel models with 3D printed of the stadium models, and we've done a lot of benchmarking. So cooling, we get the air from somewhere, from outside, cool it to a certain temperature, and we dehumidify it, and we clear it from debris like pollen, dust, and human produced debris like pieces of hair and skin, and we do recycling for that and put it back to the people. This is roughly how we produce the cold air. The computational fluid dynamics, every stadium is drawn into a computational mesh, and every point on that mesh, which, for example, in a Thumama Stadium, the one on the left, we use about 100 million mesh to simulate people on the stadium. So now every one mesh, every like 1 centimeter square of a mesh will have a velocity, temperature, humidity, and all the information on the air on that particular area, as if I have a 1 million sensors within the stadium measuring those. These are the wind tunnel facilities. So again, and printing the models. This is Albeit models. We print the models 3D printed in the university, and then we use particle image velocimetry to see how the flow and the platform of the stadium is working, and to keep that cool inside. I mean, the infiltration of wind through the open oculus for us was the main challenge, and I wanted to make sure that hot wind from outside will not infiltrate through the stadium and go in circles around the stadium. So we wanted to keep that cold bubble inside alive. So, for example, benchmarking against this is Jassim bin Hamad Stadium, or previously it was known as the Sed Stadium. So it's an air-conditioned stadium, and we use that for benchmarking as well. And this stadium in Amsterdam Arena, we used it as well for benchmarking. We've done a lot of work into assessing where will be the hot surfaces through the grass, and how the grass is contributing towards the microclimate of the stadium. And the grass is our best friend, because the grass is a life environment. And this is actual measurement taken on a summer day. You can see the running track of Khalifa. It can reach 70 degree centigrade, while the grass will be around 35 degrees centigrade, because the grass is a living organism. It's taking a lot of water, and we have evapotranspiration, and through that process, it keeps the grass surface as cold in comparison. About difference in temperature will be around 35 degrees between the hot surface of the running tracks and the grass, and how the grass is contributing as well as a cooling surface within the stadium. And we measured what is the thermal capacity of the grass as well that we use. Through the Russian tournament and the Brazilian tournament, we were putting people through air-conditioned fan zones, and we were going and asking people how is the temperature. That's in the middle of the summer as well. How's the temperature? Do you like it a little bit more cold, or do you like it a little bit less cold? And we went and surveyed a lot of people to establish what is thermal comfort in our region, and taking different backgrounds, nationalities, and gender. And because as we said, I mean, we're asking people, do you feel neutral in this weather? Is it slightly warm or hot? Do you like it slightly cool, or cold? And this is what we call the predictive mean vote. And we always, when we do our cooling, we are aiming that most of the people to feel neutral. And neutral for us, for example, this is one of the thermal comfort life studies we've done. We looked at about 532 participants, and how many of these people will feel cool, and this was just a analysis of the work we've done. Okay, so for us, we looked at that. We printed people in our stadiums. We control their temperature, and we see how these little people, which will represent the fans at the time, how they behave to our cooling packages. And you can see that's on the computational domain, and we took a strip for those. And one innovation was done here, that what is the resistance of that these people will put to the air. And then at the same time, we printed those people, we put them in the wind tunnel to validate our models on the spectator simulation. So what's helped us in the university, and this was a project where a lot of stakeholders went in, the Aspire Zone, and the Supreme Committee, and QNRF projects, and Qatar University as well. So we can print it. This is a Thumama Stadium at the time, and you can see we printed the facade and wanted to make sure how we capture the air going through that facade using the 3D printed facility. This is Al Bayt Stadium as well, all printed, and this is a wind tunnel validation to our models, and at the same time, this is how the flow is behaving, passing through people.
Dr. Saroud, just sorry to interrupt you. I'm just want to allow for a bit of time for some Q&A.
Yeah,
if you can.
only 2 minutes. I mean, I will show you. I will show you even as innovation, because we have Sebastian with us. I will show one innovation we've done that we implemented. Instead of the FIFA officials taking the WBGT within the stadiums using measurement, we put that in our case using WBGT, using the algorithm itself, using thermal cameras. We can measure that within our control room, and all the stadiums have a live measurement of the WBGT thermal index that FIFA wants. We've done solar helmets for our workers as well for cooling, and I just need to show you one of our stadiums now working. You can see this is the temperature in the middle of summer. You can see the blue is about 21. These are the stands, the upper stands at the top. This is the Thumama Stadium, and you can see the temperature we're allowing. You can see the sun radiation at the bottom, the field of play as well. This is an interesting video for us because we're telling people we are not cooling the bulk of the volume. You can see that where humid air is meeting cold air, and this is then leading to this cloud in the middle. So we are only putting the lower stands for cooling. The upper stands were not cooled, and you can see where this a cloud dancing in the middle. That means that we made sure that hot wind from outside is not really infiltrating. This is one last video, like 2 minutes, that we've done to explain the cooling technology for people in a simple term. Sorry.
So, Dr. Saroud, while the video is running, we have a few questions which touch upon these areas that I'll just pose to you as well. One of the questions is, what is the ideal temperature for players in reference to your first slides about cooling technology and injury prevention?
Can you say that again, Hinda?
What is the ideal temperature for players in reference to kind of this presentation on your session?
Okay, so for the players, we don't control temperature, we control the humidity of the air more than the temperature. But I mean, the temperature will be a comfortable 22 degrees C. But for us, it is more important to control the amount of moisture in the air, and that's what we measure in the field of play. How humid is the air, and just to help players to play in a safe environment.
Okay. Another question is, obviously there's questions around, when you're cooling air and stadiums, there's questions about sustainability of these efforts and, you know, CO2 impact, etc. So I think in the past you've mentioned that this is more, you know, these efforts contribute to sustainability. Can you expand a bit more on how that is?
So for a start, all the stadiums drawing is power from the national grid, and now on the national grid, we made sure that we through the 2022 tournament, we expanded our energy basket. Kharsa plant, which is a outside Doha, is about half an hour drive from Doha. This is a PV farm, and it generates more than 10 times what we need to run the stadiums, and it generates about 15% of Qatar daily total of Qatar daily power consumption. So the amount of power we're using, they're all coming from that clean source. And at the same time, we made sure that we have a lot of technologies to make sure that the energy consumption in these stadiums are very low. And traditionally, you know, as an international event, the most power consumption would be from people traveling from abroad. 98% of the what we call the carbon footprint will come from people traveling internationally to the international event. It's not coming from the event itself.
Okay. Another question is around, obviously you did the research and you did a lot of R&D and in terms of the designing and testing at the university. How was the process of working with the people designing the stadiums and building the stadiums? And how long did that, you know, how long was that process of working with them? Because doing something in a lab is obviously one thing, but actually making it implemented in the stadiums and for the World Cup is fantastic. So how was that process and how long did that take?
So as a university professor, you can do a typical, what I call a typical research, which is basically you have an RA working with you, with the group, and then you look through, you go through a very rigorous process of publication and the rest of it. But if you work for an industry or a stakeholder that they have a timeline, you have to be quicker than a normal cycle. So you will go and sit and you'll as a team you will lead the design, because there is no international design office that or local design office that produced this program before of air conditioned stadiums. So you have to be quick and work long hours as well in order to be on time, because at the end of the day there will be a timeline for the start of construction, freezing design, purchasing equipment, and then commissioning these equipment. But it's a beautiful journey, and it's a quicker than a normal traditional research. And what is more beautiful than having a research only in papers, and then in a 4 years down the line you can walk into your own research.
Yes, I agree. Very beautiful. I think we have time for one more question before we round up for last remarks. Dr. Kool, have you considered both heat and moisture emissions from the spectator mannequins?
Yes, I mean, it's been these mannequins, they're 3D printed and they are heated from inside to give us the core temperature. And even we put some sort of skin with moisture in the experiment, and in the simulation is much easier, of course. So it's been every one single person, the amount of latent heat, sensible heat, background radiation, the moisture coming from the grass as well as a surface has been all taken into our calculation in order to make sure that we design our packages not to be oversized, just to give you the exact neutral feeling. And these stadiums are functioning 24/7. I mean, irrespective of whatever the weather is outside. And if outside, for example, is 37, they'll still give you 2021 inside. If outside is 50, they still give you 2021 inside. So irrespective of temperature outside, the micro bubble inside will be always there.
Okay, thank you very much, Dr. Saroud. I think I'll just, if I can, invite Mr. Sebastian back to the webinar. And I'll just invite you both to say a few final remarks. We're a few weeks away from the big event. It's a very exciting time in Doha, and we're very much all looking forward to it. So I'll just invite some final remarks before we close for the audience.
Should I go first?
Yeah, please do.
Thank you. And thank you for having me once again. I think this was a fantastic opportunity. And from the questions that were asked, I can tell that some excitement is in the air, and that people are interested in these kind of technologies. For me, of course, now a very exciting time is starting. Not to say that it wasn't exciting so far, but I'm flying to Qatar on Sunday. From Monday on, it will all be operation, and I'm really looking forward to this fantastic tournament and see not just our projects to come alive, but to really experience a fantastic and unique World Cup. So looking forward to seeing you there.
And we look forward to seeing you too. Dr. Saoud?
For me, it was a long journey. It's more than 12 years journey now. So then I'm looking at the World Cup as a destination. So it's the destination where we wanted people to come and enjoy the culture and enjoy the game. And for Qatar, really to be at the world stand, just showing its culture, its knowledge, and its hospitality as well.
We're all looking forward to it very much. I just want to extend a big thank you to our panelists who joined today and shared their very interesting presentations. So thank you once again, and thank you to everyone who joined this webinar. We will be sending an email after it with a link to the video of the webinar, and also asking for feedback. But that's it. So see you all in a few weeks' time, and very much looking forward to this game. So thank you very much.